Hi Math, I'm Andy. Today we're continuing our look at compound inequalities. These are inequalities that kind of come with more than just one math problem generally. Now, in order to solve inequalities, there's just really one more rule you need to remember besides just inverse operations and combining like terms. But it's this idea that whenever you multiply or divide by a negative number on both sides, that inequality symbol is going to switch around whichever way that it's facing. It's going to turn around. So let's take a look at a problem. Let's say that we had a compound inequality that says 7 times w minus 5 is greater than or equal to 65, or negative 3w minus 2 is greater than or equal to negative 2. So let's just say that this is our problem. Now you notice right here we have this word or. This tells us that it's a compound inequality. Now the only thing that we need to remember is we're just going to solve both of these problems kind of simultaneously, and we're going to graph them both on the same number line. Because really what an inequality is all about, it's representing that this variable can have more than one answer. It's not an equal sign, but it's a greater than or a less than sign. So we need to use a number line to represent more than one potential value for that variable. Now, I'm just really going to solve these like I would an equation. I'm just going to look at the problem itself. I want to get this w by itself. I want to first undo any addition or subtraction. So I'm going to add 5 to both sides first. This is going to get rid of that 5 and isolate my 7w. The inequality symbol is still there, and 65 plus 5 is 70. Now if 7w is bigger than or equal to 70, I can use inverse operations again to get w by itself. So I'm going to divide both sides by 7. 7 divided by 7 is the 1w that I want. Because I did not multiply or divide by a negative number, I just divided by a positive 7, that inequality symbol doesn't change. It just stays how it is. And 70 divided by 7 is 10. I always like to think of these as kind of alligators. That's where you'll notice my inequality mascot in the background. And I always remember that the alligator eats the bigger number. So this is really saying w is bigger or equal to 10. Now, we had a compound, so w can have other values as well. This is negative 3w minus 2 is greater than or equal to negative 2. I'm going to use inverse operations again, kind of that undo any addition or subtraction first. So I got to get rid of that minus 2. I'm going to add 2 on both sides. This gives me the negative 3w is greater than or equal to, because negative 2 and positive 2 make 0, and negative 2 and positive 2, that also makes 0. So negative 3w is bigger than or equal to 0. I'm going to divide this time by a negative 3. And so here will be this special reminder coming into play. Notice I'm dividing by a negative on both sides. And because I'm doing that, the symbol is going to switch. So this is going to say w is now less than or equal to, and then 0 divided by negative 3 is 0. So I want you to notice that the symbol was eating the w first, but now it switched and it turned away from the w. And so I used my special reminder trick. Now with compound inequalities, it's really two problems, but we want to represent them on one number line. Because w is greater than or equal to 10, there's an infinite number of values that w can stand for. So what we do is we draw a number line, and I'm going to put the number 10 and 11 and 12 and 9 on here, just so we know that 9, 10, 11, and 12. And w is bigger than or equal to 10. So we use a closed circle to represent a number that can be equal to. And then because it's bigger than 10, we're going to draw an arrow towards all the numbers that are bigger than 10. Now on this same number line, we want to represent this answer as well. W is less than or equal to 0. So I need, this is 8, 7, 6, 5, 4, 3, 2, 1, 0, negative 1. So I got to put this on my number line as well. And now W is less than or equal to 0, so that's going to be a closed circle at 0. And I'm going to point my arrow towards all the numbers that are less than 0 as well. And so think about this. W can have more than one value, but it's going to be either less than 0, less than or equal to 0, or, so we skip all these, greater than or equal to 10. So it's like W can have one of two options. Either your W is over here, or your W is over here. And so that's kind of how we're going to look at compound inequalities.